folks, and welcome to Maths and Physics for You. In this video we are going to continue with trigonometric problem solving. In the last video we saw how we could model Ferris wheel problem, but now we continue to model the tide level. The tide level is very important in mathematics and engineering and navigation. And it's almost every time is asked in assignments in high school as well as in colleges and universities. So it's essential that we know how to model the tidal waves or tide levels and find out what times the height is high enough for ships to enter and leave ports for safety as well. Okay, let's look at this example here. Okay, let's say the high tide starts at midnight. Let's say the high tide starts at midnight, so that is t equals to 0. That's where we consider the time. This is the time axis in hours. So we start at 0 at midnight. The height is 7 meters. The high tide. Now it goes down. And the low tide will be after 6 hours. The low tide will be after 6 hours. So the height of water will drop to 3 meters. And then back again, it starts to increase. And back to high tide at 12 o'clock. That is after another 6 hours. So we are back to the high tide. So this is complete cycle. This is the period. And this means that this period is 12 hours. So the function or the wave repeats itself every 12 hours. Okay, so we start at midnight, okay, as high tide, 6 o'clock in the morning low tide, and at 12 o'clock noon time it's midday, so it's again the high tide, and so on. It goes like that. If you want to continue, it repeats itself every. All right. Now the question is to model it as trigonometric equation. Okay. So the simplest thing here, as we can see, this looks like a cosine function. This looks like a cosine function because we know that the simple cosine function, and this is x, and this is y. We know y equals cos x. The period for this is 2 pi. Half is pi over 2, and 3/4 3 pi over 2. And this one oscillates. This is amplitude is 1, so it's between 1 and -1. All right. Yeah. So we go like that. All right. So it starts from there, drops down. Sorry, this is something here. It goes like this and up like that. Yeah. So this is the one. Okay, and so on. This is the simple basic cosine function. All right, so it looks similar. This one looks similar to this one. So that's why we model it as a cosine function. But the difference here, is that the center line for this is the x-axis. That is y equal to 0. All right, this was the center line. But in this question here, the center line is here. Okay, let's use different color. Let's say this is this is the center line. Okay, so this means that the center line has been shifted up. See, from the x-axis, up. All right, to this to y equal 5. Okay, so this will be the vertical shift, which we call C. C is the vertical shift in this equation that is modeled as H equals A cos BT plus C. C is the vertical shift of the center of oscillation. This is the center of oscillation, goes up and down. All right, so that's C. We can see it's 5. By plugging it in the equation, it's 5. Now A is the amplitude. That is halfway between the maximum and minimum. Okay, so A, this is the maximum, which is 7. This is the minimum, which is 3. So the difference is 4. Half of it is 2. This is the height from the center line. So that's 2. This is called the amplitude. All right, so this is the amplitude. A is the amplitude. Okay, so that's what A, we put it in the equation. A goes. Now, B. B is the frequency. B is the frequency of oscillation. And this is related to the period. Okay, because we are talking in radians, that's why we put B equals to 2 pi over T. Okay, tells you how many cycles like per hour or per second. Okay, that's the frequency. So by putting T equals to 12, 2 pi over 12, and simplifying, you get pi over 6. So B is pi over 6. So this becomes the equation. H equals 2 cos pi over 6 T plus 5. 5 here, as you know. Why is it the number is 5? Because, you know, halfway from here is 2, and this is 3, so that the total is 5. So that's 5. The distance is 5. So that's the equation. Okay, let's say, and you can satisfy yourself by testing, putting numbers here. Let's say if at time 0 we want to check, you put T equals 0. We know that cos 0 is 1. What is cosine 0? Cosine 0 is 1. So 2 times 1, 2 plus 5, 7. So that's 7. Okay. Yeah. So let's show it here again. This is for this one. Okay, so the angle like that. This is pi over 2. This is 0. 3 pi over 2. This is pi. 3 pi over 2. And 2 pi. Okay, so as you see, this is plus 1 for cosine 0 and minus 1 for cosine pi. Easy to substitute. Okay, so the same thing. Let's say T is 6. We put 6, and 6 cancel. We get cosine pi. Cosine pi is minus 1. Cosine pi is minus 1. So 2 times minus 1, minus 2 plus 5 gives you 3. And so it goes. Okay, leave it to you to also check for this, for what the time is, 12 and 15. Okay, the question also that is related to this is to find, let's say, the captain of a ship wants to leave the port and wants to know at what times he can leave the port if he needs or she needs a minimum height of 6 meters of water, otherwise it will stuck in the flow of the sea. Okay, so we want to solve to find time. If h, that is the height, is 6, that is, let's say this is 6 here, 6 meters, and the ship needs this height minimum. Okay, so this is y equals 6 meters, and he needs or she needs to leave the port between these times, 0 and 15 hours. That is 3 p.m. All right. So we have to do the solutions up to this point. So simple here. So we replace h with 6. Okay. Solving here, this gives you 2 cos pi over 6t. We move 5 to the other side. minus 5, so that's 1. Okay. Simply now divide by 2 each side. You goes pi over 6. So this goes. So that goes there. Divide by 2 and divide by 2. So this means it goes pi over 60 equals to half. Now to find t, we say pi over 60 equal to cos inverse, half of half. As you know, which angle has its cosine half? Is 60 degrees, or pi over 3. So we say equals to pi over 3. Now, or it could be on the other side. So if this is the angle here, pi over 3, the cosine is half. It could be on this side as well. All right. Actually on this side. So it's either pi over 3 or 2, we can say 2 pi minus pi over 3. That's why we put there pi over 3, or 2 pi minus pi over 3, which is 5 pi over 3. Okay, so we got it from this or this one. Okay, say take the first one, cancel pi with pi, 3 and 6, 2, and by solving that, t1 is equals to 2. So that means at 2 a.m. So you look at it, that's there. This is 2 a.m. Same thing here. If it is 5 pi over 3, similar substitution, and we get t2 equals 10. So 10 o'clock. So this corresponds to 10 a.m. This is the second point. All right, because the period is 12 hours, the simplest thing is to do is to add to it 12 hours, because it repeats itself every 12 hours, correct? So we say T3 is 2 plus 12, 14, which is 2 p.m. Okay, so this here should correspond to 2 p.m. if that's there. So this is 2 p.m. Right? And so on it goes. Okay, so this means only this time and that time. So it's now self-explanatory that this lucky captain needs to leave as soon as possible, between 0 and 2 a.m. or between 10 a.m. and 2 p.m. And there you have it, folks. Thanks for watching. Please subscribe and see you in the next video.